You're listening to a 4x4 Radio Network podcast.
Thou hast revisited.
Yes, I do see the little red light by the button that says we are recording.
Mm-hmm.
Hey, folks, Kevin here. Scott chortling, as usual. Welcome to show 185.
Yep.
We just figured out, we sat here and calculated.
We mathed.
Scott mathed, so I calculated. But regardless, that we will pass 200 shows this year.
Yes.
Probably sometime in November.
Yes, I did the reverse edition and figured that out.
So anyhow, thank you for listening.
Yes.
For almost 200 shows.
Mm-hmm.
That's awesome. Anyway, welcome to On the Trail with Kevin and Scott. I'm Kevin, the engineer. He's the guy that reads instructions, generally follows them, uses the right tools, unless I'm getting creative deliberately, and then I take the risk on myself. And you are?
And I am Scott. I am the slapstick parts guy that is continuing to try and understand and go through the motions of this podcast to try and make myself sound more intelligible and intelligent with every day, which actually, we all know that's a facade. I'm actually really smarting stuff. But with that, while we always share what works for us as well as what didn't,
Which
please.
has happened a lot lately.
Which has happened a lot. Nothing is a greater teacher like your own oopsie and a boo-boo strip.
As long as it's just a Band-Aid.
Exactly. So while we share with you what worked for us and what didn't, please all remember to read the instructions, do your research, and follow them. Not necessarily in that order, but you get the idea.
Yeah, follow the instructions, please.
I won't get it right.
Well, this is true. This is true. And today's tech topic is brought to you courtesy of the internet.
Yeah.
Not a sponsor, but a never-ending source of interesting concepts.
You just broke me, dude. You just broke me because when you said that this show brought to you by the internet, my gear just went, which is actually rather poignant because someone took a bag of marbles and threw them in my rear end differential. Wow, it's a good thing I prefaced that by saying differential. Moving on, family show. So, Mr. Kevin, we're coming fresh off of Jeep Beach.
Yeah.
Hopefully, my head doesn't burn too much. No,
No, only mild bacon frying, not
pulled pork. Smells like pulled pork.
There's so many wrong things to say here. So,
Is that suntan lotion? No, barbecue sauce, Carolina style.
ow. That vinegar would be
In
a
my
little
eyes, in my
That's
eyes.
exactly what I was thinking.
So we hope everything went well. You hope everyone traveled to and from safely. You had a good time of the event because obviously we're pre-recording this, so we don't know what happened. So hopefully everything went well and no one got hurt and everyone's Jeep came at least in one major piece.
Or at least left in one major piece.
Yes, that too.
Anyway, the tech segment. Shall we jump into that, or is there any
Let's
other?
get right into the tech
Yeah,
stuff.
since you're doing
because
so well.
I am field on Monster and barbecue.
Yep, Mission Barbecue.
Let's not go there.
Yeah, let's go there. What I want to chat with Scott and you about came from a multitude. I don't know what it is about this month, that April, that maybe it was just thawing out and people are starting to get out and wheel. And, at least down here in the South area. And there's been a host of... Scott's over here turning purple.
I'm just over here going, welcome to April. It's Differential Awareness Month.
Well, yeah. And it's not that kind of differential. I'm talking about those two little funny drumsticky like things under your Jeep that your wheels are bolted to.
My favorite line of all time is, hey, yeah, my front rear end differential is leaking. Got to use it once. Moving on.
And I'm sad to say I've actually seen that a time or two or something similar.
But that's where we come to learn, right?
Yeah, well, this rash of questions on your rear end. Well, it was.
Here comes the diaper cream.
No.
I would try and say the name, but I'd say it wrong and would get flagged.
Well, it was
for
on your
naughty
front end
words.
too, but that sounded worse.
Oh, family show. Moving on.
What did I say wrong?
I don't know. Now I'm thinking of tubes of per cream. I'm not going to say the first part because, again, I don't want to get flagged for using naughty words.
Okay. Anyhow, several articles and quite a few comments, as well as a few other posts and even a few YouTube videos talking about what happens when you lift a Jeep. And how in the bleep, bleep, bleep do I check my oil level? How do I know if I have oil? What is this doing to the differential? Am I messing anything up? Can we go on with any other questions or comments, Scott, that are family suitable?
I'm trying to do the best I can.
Okay.
But no, it actually is a valid question, because when some people say if you follow the arc when you raise the vehicle, you change that pinion angle.
You do. And so let's start off with that very thing. When you lift a vehicle, in most cases, mod lifts, you might get away with the stock pinion angle.
Yeah.
For those that don't know, pinion angle is simply the fact if you take an imaginary line through the center of your wheel and then rotate it, usually up in a Jeep, until it lines up with your drive shaft. That is essentially your pinion angle. And yes, it can vary a couple of degrees either way, depending on. So don't get me on the technicalities here, folks.
There's a lot of things in play here.
Verbally explain. The nose up syndrome is the best way to think of it. The nose, where the drive shaft hooks in, goes up to point at the transmission and transfer case.
Yes.
So I'm not going to get into drive laying angles on this discussion. But rightly so, people have said, but when we do that, I come back and I check my differential oil and it pours out the check hole.
So it must be fill, right?
Yeah, it must be full.
Fill.
But because it's rotated, that hole is now lower than it was from the factory. Well, okay, if it's lower, and I've seen people say that, well, no, you need more oil. Well, how do I get oil in there? How do I know how much is enough? What do I do with that?
I'm pumping as fast as I can with the pump.
Yeah. So here's the thing. Differential rotation. We're talking about not turning gears, but actually twisting the axle so the nose or input, whether it's the front input on the front axle or the rear input on the rear, does change the hydrodynamics. And yes, it's not really water, but it's oil dynamic flows inside the differential housing. Overall, things function about the same, but you have changed a few key things. But I have a hand up here on the front row.
Well, let me ask you this question, because in the land of other topics of, well, what other kind of stuff should I do to my Jeep? Why is this topic so important?
Well, unless you really like the screech and stench of a burnt front pinion bearing or the grinding of outer axle bearings self-destructing.
What?
Yeah, you may want to pay attention.
Well, this is important. Not a lot of people think about this until you really start thinking about it.
Until something goes wrong is usually what happens. All right, so what we're going to start off with is how does a differential lubricate itself? Because it's its own pump. But if you've ever torn one apart, there's not a pump you can see, or so you think.
Right.
What you have inside, for those that haven't actually had the joyous experience of being into 90-weight gear lube up to your you-know-whats.
Oh, the smell is beautiful. Yeah, I love the smell of hypoid gear oil in the morning.
Particularly when it's used and abused. There is a shaft that comes in. It's got the yoke that the front of your drive shaft is mounted to through a U-joint, and that spins.
Oh, the spinny bits.
And the other end of that shaft on the inside has a gear that kind of reminds you of a very heavy mallet, a maul, or something like that. It's a gear, except that the gear isn't straight cut. Yeah. It's larger at the back near the shaft and smaller at the front. So it's kind of wedgie shaped. And the gear's teeth themselves are spiral.
Yes.
Okay. That's what makes it a hypoid. And hypoid simply means that you have a 90-degree gear train, nominally 90, and the center line of the input shaft on the pinion and the center line through the ring gear and your differential assembly inside don't line up. They're offset either below or above each other's center lines.
Gotcha.
There are two bearings on that pinion shaft, as short as it is. One is right behind the gear head, and the other is way out at the nose next to the yoke where the drive shaft. And between that front pinion bearing and the yoke, there's a seal that's supposed to keep the 90-weight gear lube in.
Yeah.
In Jeeps, it's notorious for letting a little out play hooky. And we end up with that arc of oil coating that keeps that one strip above the front and rear differential noses rust free.
Yeah, I was going to say, it's like
There is a benefit.
90-weight undercoating.
Yeah, pretty much. Now, when you're going to look, you don't see a pump. You don't see, okay, how does it get lubricated? Because these are some beefy, tapered roller bearings. And they need lots of flowing lubricant to not only lube them, but also to cool them. Oil is the coolant in the differential. Well, we'll get to how they get oiled in just a moment. Now, that little club that turns in there with those beveled, spiraling gears turns a ring that has curved spiral teeth that mate to that gear. And that ring is mounted to a part called the carrier, which is just this little cylindrical carrier. And on outer sides of it, right and left, if you want to call it that, with the pinion being front to back, are bearings. And they go into a holder assembly that keeps that carrier in place so that ring gear can spin around in a circle that's the same rotation that your tires are doing, okay, in that plane. And the pinion gear is what turns, engaging that ring gear, making it turn. That whole mass, okay, is hollow. So inside that carrier is a space on an open differential where you have your spider gears. And those spider gears are just 4 small gears. They're only about 2 inches in diameter. They're beveled at 45, nothing special about them. 2 of them that point in line with the tires are what your axle shaft plugs into. The other 2 are actually held in the case. So when the case turns, when the ring gear turns the case goes, and the 2 outer spider gears turn, they drag the 2 facing spider gears that are on your wheels along with them.
Yeah.
And why do we have that complicated thing? So that when you go around a corner and the outer wheel has to go quicker, those gears will turn on their shafts. The case gears will turn, whereas the other ones won't. And you get differentiation, which allows the outer wheel to turn faster than the inner. But power is still flowing to both of them. Mm-hmm. All right. The downside is power goes to the one with the least friction, which if you're on ice and have one tire on ice and one on pavement, the ice tire spins like crazy.
Yeah.
Now, we're not going to get into it because you can replace that carrier with a locker, with a limited slip, with all kinds of other torque splitting devices that take the carrier rotation and make sure it goes to both wheels equally. Most of one wheel 80%, the other 20. Those are your choices. And we may talk about those on another show. Mm-hmm. We talked about it on a show quite a few years ago with Ox Locker. But anyway, so that's the basic assembly. Now, we can't forget that the outer housing that holds all this stuff in and the oil in also has to hold these funny little pieces of donuts at the end, that, we commonly call rims and tires. Mm-hmm. Well, they have bearings out there as well. And they're what take the vast majority of the load of your Jeep as you bounce along rocks, run down trails, or zip down the highway at, dream on when you say 90 miles an hour. But,
no, there's some people that do it.
I know.
Hashtag send it.
Send it, and then particularly the Hellcats. But anyhow,
as they send their spine to the top of their head.
That should be too. So how do you get oil down there?
Yeah.
So this is where all of this starts up. So if you can imagine, I've got this tank that's got a bunch of bits that are spinning around inside of it, but I got to get oil in there. And then I got to get that oil around to all of these bearings. Mm-hmm. I also deal with the fact that as this thing runs, it gets warmer. And when things get hot, they expand.
Yes.
Including the air and oil in that volume. Mm-hmm. And so how do I keep it from pushing the seals out and leaking? So if you kind of got a picture, if not, Google a little bit and go take a look at what you can find on differential cutaways and things like that. There are some really nice ones out there. But let's get back to a factory installation. In a factory installation, the idea is the axle tire to tire is basically horizontal. All right. Front to back, from the back of the differential to the nose of the pinion, is usually tipped up anywhere from, let's say, 4 to 7 degrees to match the down pitch of the engine, transmission, and transfer case combination. That is so that your drive shaft input angle and output angle are matching, opposite but matching. That minimizes vibration. That makes the whole system work better, smoother, etc. We've talked about drive shafts before. So when you lift a Jeep, they don't line up anymore, do they? No, I have to rotate the pinion up. Oh, gee, now I don't, you can drop the tail of the engine, but then that kind of defeats the process. So then we start messing around with, well, let's do a double cardan at the top end. And that's even already in a Jeep that has the Rubicon models already have a double cardan at the top end.
Right.
That's essentially 2 U-joints and a very, very, very short, like 3/4 of an inch long drive shaft, locked in the housing. And that is your drive shaft. The part that's going all the way down to the actual differential is just an output shaft, technically. All right. Now, that doesn't have a mating U-joint because you've taken your input angle and your output angle up in the double cardan. So down at the bottom, you're going to be setting that pinion angle. So I'm pointing as close to directly at the output of that double cardan as I can get, minus or plus 1 degree. That's so that you have a little bit of a variation, not enough to shake, but it's enough to make the needle bearings in the U-joint move around and it not to seize up over time from lack of motion.
Right.
That's all I'm going to get to on drive shafts. But what's the end result for the differential? The nose is higher. How much higher? Depends on your lift. I've seen some that look like they were, well, I can't say what they look like, but, teenage boys. Now.
That's going to get us a letter.
All right, I've tried to find something. Yeah. But the downside to that, and people see that, and there was a lot of question about how does the oil get up to the front pinion bearing? And, well, we'll talk about that in a moment, but there's a problem they're missing, is the cover is now at the back lowered. The hole that you filled through is way lower, sometimes inches lower, not just a half an inch,
Right.
So how do we know where to fill to? We'll talk about how, because you may have the essence of a hole underwater like you have in a boat.
Yep.
That's going to make it a little difficult. But let's start off. According to every manufacturer that I was able to research, I'm not saying that you guys won't come up and tell me, oh, well, but the Yak 2732 from Russia in 1927.
No, there was a difference.
Yeah.
That one uses Sperble bearings.
So anyhow, most of them all show that the manufacturer's desired oil level, cold, operating on a level surface, not
Right.
operating temp, but cold, is that you have about 1 bearing roller's width of oil across each tube into your outer wheel bearings. So if you can kind of look at the back end of your axle and kind of eyeball it, you're going to see that, I'll use the common Dana 45. I'm sorry. Yeah.
44?
Dana 44. Boy, I'm brain dead.
There went our street cred.
Yeah, the Dana 44. You're going to have about a 1/4 inch oil in the bottom of each axle tube at rest on a level surface. Now, that's not a lot of oil because it's a tube. So if you think of the bottom of a pipe, it's a little curved section, and it's only a 1/4 inch deep at the center. That brings you up to where the carrier bearings are actually bottom edged immersed or nearly immersed. The wheel bearings are immersed. The lower pinion, the inner pinion bearing may be on the edge of immersed. It may be a 1/4 inch away.
Right.
But your nose bearing isn't at that point. But don't worry about that. We'll get to that. In a normal operation, if you open almost any low pinion differential and pull the ring gear out and look in there, right in front of the ring gear, you'll see a cast opening that goes forwards up the nose in that little bevel section that you see when you look under a differential.
Right.
And that's a pipe, and it leads right into the cavity. It literally aims at the front bearing, but it fills the cavity between the front pinion bearing and the back. And many, many, many thanks to Gail Banks of Banks Engineering, who did a study on oil flow in differentials to the point of manufacturing plexiglass clear covers to see the oil flow and see what the different covers do. And if you've ever noticed on a stock stamp cover, there's a trough where the ring gear goes. Well, that trough is actually there as a guideway because the ring gear acts like a paddle wheel, a really, really aggressive paddle wheel.
Yes.
And it grabs that oil and it sends it screaming up around the top of that paddle wheel. And that cover is there as a guide to keep it heading with the wheel. When it gets to the top, it opens facing forward. And all that oil goes flying straight down that passageway. What doesn't go down the passageway goes right down the walls into all the other bearings in a virtual tumultuous storm of flying oil.
Yeah.
And your normal driving sends more than enough oil down the tubes to each wheel bearing over time. Now, perhaps if you're doing nothing but NASCAR turn left, you might want to do supplemental oiling for that poor outer wheel bearing, but they take care of it their own way. So that's kind of how oil moves. The ring gear is the pump. In addition to being the driven gear, it's picking up oil, carrying it in a trough. It's the best way to think of it, like a paddle wheel, and flinging it at a very high rate of speed all over the interior of that differential.
Yeah.
And remember, the oil is there for two purposes. One, it's lubrication, but two, it is the cooling fluid. It needs to contact the hot components, the bearings and the teeth, in quantity to draw off the heat. And then it's supposed to then splash against the back cover and the rest of the cast iron and transfer that heat to those metals where they then transfer it to atmosphere.
Yeah.
So you rotate your pinion up. Well, the good news is the pump shoots up. The bad news is your pinion still has gravity working against it.
Yeah.
It gets worse, folks, when you use an aftermarket flatback cover. They advertise about how well they cool the oil. That may be, but they also open up that trough, okay? You're not pushing the oil in a guided trough to build up velocity. In fact, a lot of it slings out sideways from the end of the teeth. And again, Gale Banks makes an excellent video on that, and you can see it with your own eyes.
Yeah.
So what can you do about it? Well, number one, and the only thing you really can do is make sure your oil level is at the right level. Well, how do I do that? Okay, I've turned the pinion up, or the shop that did my lift turned the pinion up, and now my bolt hole's too low. Well, one way is just look at the manufacturer's spec for that differential and see how many quarts it's supposed to take, and then be somewhat religious about filling it to that level. And you can do that in certain models of 44s and other that have a supplementary fill hole up in the nose, you know, on the side of the nose. I think, Scott, for your edification, it's right there, okay?
Oh.
And it's right behind the head of the pinion in some of the models.
Right.
Sadly, it's pretty rare.
Yeah.
All right. But that's a great place where you can fill and check your oil level. The second way is you can take a plastic pipe plug that fits into your drain plug and a piece of clear plastic tubing. And you screw that into your drain plug. You connect the pipe to that plug. You know, you drill a hole in it, you make it a little undersized and squeeze the pipe so it goes up in there. And then you bring that tube up and use nothing more fancy than a piece of, blue tape, and tape it to the axle tube.
Okay.
And then you start filling. And you may have to actually use a funnel or something that closes off the or seals around the fill hole so that you can pour oil in. And as it pours in, you'll notice something. It'll flow down into that tube. And even though it's open because you put the top of that tube higher than the axle, it'll rise to the level of the oil in the housing.
Okay.
And you can continue to add oil until that comes up, I'm going to say approximately a 1/4 inch below the bottom of your axle tube.
Okay.
And you have the line. Now, if you're really fast, you can stop there. If you're like me, a little fumbly, I'd put a little extra in there, maybe another 1/8 of an inch or 1/16 of an inch, because you got to unscrew that plug. With it, got oil in there, and then get the plug in without losing too much. Yep.
Could you add a hose, just thinking outside the box? Mm-hmm. You know, it takes 2.1 pints, whatever it is.
Quarts.
Quarts. Couldn't you just fill it through the breather tube? And
It would be a long, slow process.
Okay.
But yes, you could. But that's a very small port.
Gotcha.
The key here, though, folks, is you want to get the oil up at least to the bottom of the axle tubes by whatever method you can. Now, if you have a steel diff cover and you have a welder, I'll give you one. You take the cover off, you mark it where the bottom of the opening bung would need to be a 1/4 inch up the tubes. And you cut the old bung off, you weld that hole up, you drill a new one, and you weld the bung up in the right spot. You just had yourself the easiest and quickest fix you can get.
And you're built in that butt.
Yeah. The other ones are to get some of the covers that are made nowadays have an ultra high fill hole, and then multiple small sighting plugs. And you pick the one that is at the closest you can get to your level of just to have that 1/4 inch of oil flowing down your tubes, axle tubes. And once you do that, you paint it red or something that stands out so you remember that's
A big
that's
old Y on it. Yes. Rest no.
But the other method is to do the process, and then you're going to have to do speedy hands and pull out your fill plug, your filler, and then shove in a plug real quick there, and then take a deep breath. And although I did see somebody say, well, I park on a hill when I do that. Well, that would probably work, after you've put the oil in, drive very carefully to a really high hill or jack it up with a jack. But you got to get that drain plug out and put the plug back in and seal it up and not lose a lot of oil. Is it rough? Yeah, but we modified the design. So we either modify the cover to get us the right level. We get a cover that allows us to check it at the right level, or we have to come up something creative to make sure that the oil is in there. It should lubricate the front pinion bearing if there is sufficient oil, even tilted up. You get up extreme. You get really, really extreme. I'm going to say above 10 or 15 degrees of up tilt. Mm-hmm. You may have some problems with your front pinion bearing. And I don't really have a good answer for you there. Yeah. That may be grounds to take a look at a top loader axle or something like that. Mm-hmm. But for most of us that are operating in the under 10 degree nose up, I think I'm running 6 right now, and it's run great. But I use a stock style aluminum cover, so I still get the cooling benefits, right, but it maintains that trough-like area for the gear to carry the lube. And as Scott knows, I boogie down the road pretty good.
Well, it provides a highway and a path for the lubricant.
Yeah, and that's the key there. So the other part that I wanted to mention, venting. Most differentials are vented through the axle tube to a little hose. Typically on Jeeps, it's on the passenger side, and it's a little rubber hose that goes up. Some of them are on the driver's side, and it goes up, and it usually goes into the gas filler area, and it's just zip tied to the gas fill lines with a little vent filter on top.
Yeah, a little white plastic cap.
Yeah, either white or black, but yeah, and it's to allow, as the differential heats up, the air can expand and go out. Theoretically, the axle tubes shouldn't be under oil at the top. That's one of the reasons, even if you're side hilling it, that the differential vent tubes are almost at the differential, because you could fill up a whole lot of axle temporarily off camber and not flood your vent tube and spit oil out. But if you tilt your axle up high enough, you can start getting oil out your vent tube. And if you do that, you may need to put a pipe plug in that hole and drill and tap a new hole. That could introduce chips. There's many tricks to drilling into a sealed container by dipping the drill into grease and then dipping the tap in grease and using that to catch the chips. Is it perfect? No. But, it's either that or open up the differential, drain it out, pull that side axle, and then pull a rag through the pipe from the inside to the out with a string or a broom handle, a long extension, anything. You get the idea here. You wipe it out afterwards.
Yeah. Get the chunky bits out.
Get the chunky bits out, because even a small chip from a quarter inch pipe bung tap can permanently damage your differential gears or destroy a bearing.
Absolutely wreak havoc with it.
As weird as it is, as nasty as the outside of an axle looks, the inside is hospital clean, or should be.
Yeah.
Lastly, you'll also know if your differential is plugged. I mean, your differential vent is plugged if you start weeping out pinion bearing seals or axle seals. Usually they don't fail on their own unless you're in the north of 150 to 200,000, and then they're just worn out.
Yeah.
But beyond that, if your vent gets plugged, temperatures rise more than enough to cause pressure to blow out your seals. And before you go, oh, that's gross and messy, and I pressure wash under there, that's fine. But just remember, that's oil that you're losing. Mm-hmm. And if you lose oil too much, you're not going to lubricate that front pinion bearing, and then you're going to have, expensive parts, maybe even a new axle if it spins the bearing, the outer race bearing.
Yeah.
And we have had those where it took me, a friend, and a sledgehammer to remove some toasted pinion bearing. Fortunately, the housing survived.
Yeah.
I don't know how. We had written it off, and it's just like, it was one of those, okay, I'm going to see if I can get this out. It was a high pinion, so that was why it was worth a little effort.
Oh, yeah. Well,
so, I guess, any questions on your end, Scott?
Well, the most common question we see a lot of, and I want to say maybe 5 to 6 times a month I see this question, is the hose hanging down under the Jeep. Hey, I just saw this. What is that? Majority of the time, it is that vent hose that's popped off, because a lot of them don't even have a hose clamp. They're just pressed on. They're
pressed on, and if you lifted without extending that hose, it's going to pop off.
Yeah.
I have, and you know what? I just bought a regular section of, I think it's 1/4 inch hose, might be 3/16, but I think it's 1/4 inch vent hose. You can buy a plastic to plastic coupler, or use a piece of steel if you're worried about the plastic, and then a couple of spring hose clamps. Mm-hmm. You can use the bigger ones, but they're heavy with the big screw on. I kind of like the little squeeze ones that you just put on there. I know there's a love and hate, but I'm not talking about a pressure situation here, guys. This is just to hold the hose
just
on.
A vent hose, yeah. That's what I did on the JK.
But I added about 8 inches to mine because you forget. Oh, it's fine. Okay. Have you put yourself on a flex trailer and dropped that axle all the way down? Or have you gone up an RTI ramp? We've done that, and we've seen those things banjo tight.
Yeah.
And so make sure that you have at least as much slack as your suspension travel goes down, or you're going to have problems. In fact, there are worse problems, Scott, I've realized.
What's that?
Well, the older ones like my TJ and your LJ, they have, steel or brass fittings that hose connects to on the axle.
Right.
I am seeing new ones have plastic fittings that screw into the axle, and the hose is white plastic and black plastic.
I am rubbing my forehead with that comment,
because you haven't looked at the Gladiator, have you? We'll have to go check that one out. But
great.
I have seen a few of those come into some of the shops, and it snaps off the plastic pipe. Now, the good news is there's no shards, and even if there were plastic, but I don't recommend putting plastic back.
No.
If you're going to do that, get yourself some, real fittings, even if you got to go junkyard diving.
Be right back. Joking. I'm joking.
Anyway, folks, I hope this has been a little bit of an informative bit of information on how and why and what our improvements do to the actual mechanism. When we start lifting Jeeps, that's what we talk about. You have to know that everything has a cause and effect. Suspension lifts are great. I'm not going to argue with it. I run my metal cloak, and I love it, okay? But I know what has happened to the differential. I knew to extend my pipe, as far as the venting, and made sure that I had a good oiling system in place, i.e. had the right differential cover on to make sure the oil went places that it was supposed to go.
It's funny you bring this up, because I remember when the JK came out, and everyone was lifting their JKs, and everyone kept saying, well, the insurance company, I avoided my warranty because the guy at the dealership said, the pinion problems. Yep. Now there might be something to that now.
I think there is, because it is.
It's viable from what you just explained. You're starving. You in some certain situations with some lifts, you can starve that front pinion bearing.
You really can. High angle lifts are very, very hard on the nose pinion bearing. That's all there is to it. particularly if you put a lift, if you do a re-gear and they do a cheapy aftermarket, no-name brand master install kit with those wonderful Pladonium and Chinesium bearings, that's versus, some top-end brands. If the hardening isn't spot on because you are, even if it runs well lubricated most of the time on the highway, if it's marginal and you're doing a hill climb with a lot of power, you could starve that pinion bearing. Yeah. And no, the first time it's going to have enough oil that it may only did one small Brunel, which, by the way, is a small wear point where the metal transferred due to heat and pressure from one tooth to its mating tooth. But once that happens, that pit continues to eat the other teeth, and that bump now on the first teeth starts making new pits. And from that point on, it's an ever increasing speed of failure. Now you're making my throat clog up.
I know it's. I still have this problem with the stuff. Hopefully, whatever it is, it'll go away soon.
Yeah,
but I'll walk it off. No, and again, that's we actually had a friend of ours. Forget the slinger, and Dave. I can't remember his last name, but worked with Brian.
Yep.
And was it with the slinger, or was it using the Lucas oil stabilizer, but never actually using gear oil in the front?
That was what his was. He had the slinger in, but he used 100% Lucas, thinking, well, if a little's good, a lot's better.
Yeah.
And unfortunately, Lucas has its place. I'm not trying to say it doesn't, but as 100% the lubricant, it does not flow sufficiently. And therefore, it starved the front pinion bearing. And that's exactly the axle I was talking about, where he fused all the components together.
Gotcha.
Even though he's going, but it's completely full of Lucas. Well, yeah, but Lucas is an additive. It is not the primary oil.
Yeah.
And that's another thing I'll say is don't overrun thick oils if you're not in the environment where you need thick oils. Mm-hmm. Even here in Florida, we're not in Saudi. Okay. I don't run anything higher than 140 multi-grade. I run a 9140. 140 is good for hot weather, but sorry for the thump in the background. That's somebody drove by with the boombox car. You can actually be too thick to flow. Mm-hmm. And if it's too thick to flow well, it may lubricate, but it won't remove heat. There's the two properties, and people just always forget about that, is lubricity and thermal, carry. Yeah.
It's funny you talk about that because younger in my days, with the parts trucks we had were Ford Ranger, the twin the 2.3 twin spark Ford's 4-cylinders. And we'd always use 2050 motor oil in those things, because, again, they were beaded like a rented mule. Mm-hmm. Well, I got my own Ranger because I love the truck and it was dependable. And I put 2050 motor oil in it. But bear in mind, it had a nice, more cushier lifestyle. It was a cold morning. It was like, 42 degrees outside. I started up. I'm like, And once it finally warmed up for about a minute, it quieted down. But I'm like, okay.
How much damage did you do in that clatterfest?
We're getting 5W30. I don't care. I traded in soon afterwards. But the point is that, again, that's even some of the questions people are asking now with the Gladiators. And where I'm at now, I'm on a certain name brand truck that starts with a T, Toyota, and we're on our third V6 twin turbo, and we're now getting the Tacoma.
This is your company,
V6.
right?
Yeah, the V6s are now having problems with valve train and leakage and engine problems because of the 0W20.
Yeah.
A lot of guys are starting to think that's just a little too thin.
It can be.
And even the Gladiator's a little noisy in the bottom end.
Yeah. Yeah. Well, the thing is that oil is a balancing act. All right. As people, why can't they just? Well, they can't. Okay. It has to have a certain body, a certain number of, centipoises of viscosity to support. It literally supports the rod and bearing assembly so that it doesn't drag the crankshaft and camshafts.
It has to withstand a certain PSI.
It has, well, not only that, but it then has to do that without side support or with limited side support. You think about it. You have side-to-side in play, don't you? Mm-hmm. And between your rods and your crank and your cam followers don't have anything on either side of them. All right. So there it has to keep the metal from contacting each other without squirting all the way out under the highest pressure point in the piston stroke or in the cam follow. And that's a tall order, but you want it really thin so it flows really well through the turbocharger.
Yeah.
Okay. And where do you get that happy medium? You're down to the point that the turbocharger can take something this thick, and any more than that, it's going to fuse. But I'm down here with the connecting rods and lifters, and they can't get any thinner than this, or they'll do metal-to-metal contact.
Right.
And sometimes with tolerances, temperatures, and manufacturing, we get a gap between those two. There's no overlap. And we have seen the world and the focus on economy and fuel economy and absolute purchase price. We've crossed in some of those lanes, where we've gotten to the point that we are into what they call tolerance failure. Mm-hmm. Every part's within tolerance, including the oil. But they're all at opposing ends of their tolerance spectrum, and there's a gap in there. And that's the engineer's fault. And I say that as an engineer.
Yeah. Is
that when you get to where the tolerances can have a fault, mm-hmm. you're gambling. You're saying, well, it could happen, but it's minuscule.
It's cheaper to fix in the fuel, because that's a question I have, is because Toyota is known for their dogged reliability. Let's be honest.
They were, yeah.
But even Ford is having issues with their motors.
Yep.
I know Chrysler's having issues with their motor. This all comes from the post I saw about someone putting 5W30 oil in the Gladiator. It's supposed to have 0W20, but I know in the Charger I had 2012, which also had variable valve technology, used 5W30, and I got 150,000 miles of noise-free out of that engine.
Yeah.
I am at 76,000 miles, and on cold starts,
you're hearing it.
About 4 out of 10 starts, it sounds like it's time to change the rocks out of the motor. Mm-hmm. And now I'm hearing, when I exited the highway today, I'm hearing bottom end clatter. Yeah. And it's getting louder and louder and louder. And I'm like, okay.
But you've already at least been into the dealership on that several times.
One time. I've already put it on record. But see, I'm noticing all these other manufacturers, and not to put on my tinfoil hat, but someone kind of said, vehicles nowadays aren't made to last. It's almost like they're pre-engineering. Everyone wants a battery-operated car, but we're not going to go down this because this isn't a political show.
Yeah.
But it does kind of raise a question of, what happened to the dogged reliability we all used to have?
Well, you said it yourself. Dogged reliability is a good in certain situations, but it does not bring in new revenue.
Yeah.
If you tried to make the automotive business on a one-person, one-purchase basis, just about every manufacturer would fail.
Yeah.
They are counting on repeat business. And I can't blame them for that, okay?
No.
Otherwise, we'd still be driving the
Model T.
Well, I wouldn't go quite that far, but I would probably be saying the early 80s Toyotas and the old Ford Power Stroke 7.3s. Okay, there were vehicles that were dogged reliability. Unfortunately, they were not very fuel efficient, and they were pretty polluting. Okay.
Yeah, a couple of polar bears are coughing like I am right now. But it's kind of interesting you talked about today, because we're working with his computer, and Bing decided to give him all the information he thought he wanted. And I told him, I said, I'm going to put a sidebar in because I'm going to tell you about this story later. I actually had a near meltdown myself in the Gladiator, because now, and your Ford's doing this, is, it's time to update your stuff.
Yeah.
And I was like, I kept putting it off. Like, no, I don't want you to, why are you putting a firmware update on my vehicle? I don't want it.
Yeah.
And of course, it eventually forced me to do it. Like, I couldn't change the volume of my radio. I had to schedule that update. So now everyone talked about the iPhones where it had a situation where, like, it's engineered the battery life to be bad. It kind of makes me put that tinfoil hat on for a second, going, what are they doing to my car?
Yeah.
And that's the Gladiator, because I get emails about, do this with your Gladiator, sign on with these programs. I see the new Jeep came out with a new grill because they're trying to freshen up the JL platform. But again, it kind of like, it really raises that question to me, like, an off-road vehicle that's supposed to have the reliability to go out and do these things and be in these all-weather environments. It raises questions.
Let's throw a different concept in there, and I think it may open a door for you.
What's that?
And that is, your definition of reliability is too big. In the automotive world, and I haven't played in it, to be honest with you, other than in collaterally and then as a consumer myself, But I know in engineering as a whole, there's a difference between survivability and reliability.
Okay.
Jeep has focused on survivability, not necessarily reliability. Reliability is the fact that you're going to come out every morning and it's going to start. You're going to put it in drive and it's going to go. All right. That really hurts them in the maintenance world. All right. Survivability. I'm going to take this thing out here. I'm driving it already, and I'm going to take it up Mount Rushmore.
Okay. No, that's fair.
I just climbed up, President Lincoln's nose. It survived.
Yeah.
Okay. It's tough. Tough is not reliability. Tough is survivability. Do you see the difference?
It's interesting how we have this come full circle.
Yeah.
Because, it's no secret. We record shows sometimes in bulk. We just had this conversation.
He means like 2 at a time.
About the GPW.
Yeah.
About how much it is such a maintenance hog. I mean, yes, it can go a couple extra days and,
it's
get you off that mountain.
survivable. It's an Army vehicle that'll get you home in a pinch.
Man, do you need to do every single little thing is manually adjusted by guess what? You.
Oh. Well, you don't have a maintenance brigade behind you with a supply of vehicles turning them over. We talked about that when we talked about your seat and the Ford stamp, that this was a maintenance vehicle. When it broke down, they brought it in, dropped it off, grabbed another one, signed the papers, went off and completed the mission. The mission didn't wait on the vehicles. Okay. And there was a crew that was their job.
Not again to fix it.
On aircraft, same thing. More hours in maintenance than in the air.
Okay.
You look at that.
No.
Maintenance to flight hours. It just wasn't reported because in the time of the birth of the Jeep, every vehicle was like that. You couldn't even get through. The reliability factor was stupidly low, okay? But it was the new technology. It was the iPhone of its time. But you drove with a toolbox, with spare tires, with tools, spare spark plugs, and if you didn't know how to make it work, you switched back to your horse.
There is a generation of listeners right now that's going to sit there and go with the record when I say these words. Autumn has been studying the book and really trying to watch all these videos and really trying to learn. She struggles with a lot of things.
All right.
But the funniest thing, but her spirit's there for the most part. And what got me and made me go, what? Is when they're talking about, we saw this World War II, keeping your vehicle alive on the battlefield, and it's vacuum gauges and all this. And make sure you check the points and condensers. What's that? Don't worry, hon. You're going to learn. You're going to learn soon enough, and we're going to hear the cussing.
Oh, I'm waiting till she touches a spark plug wire that's got a crack in it.
No, I'm not going to do that to her.
No, I don't mean you're going to do it. It's going to happen.
Yeah. No, but again, she's taking this in stride, and once she saw what it was, she goes, oh, okay, so that's something I'm going to need to adjust it. And she goes, okay, let me learn on that.
Yeah, we had a little course the other week when we were working on the carburetor. We talked about 2 weeks ago of adjusting the idle, because this is 100% manual carburetor. It doesn't even have a choke. It has an enrichment circuit that got a lever.
Circuit. Everyone's going to, where's the wire?
Not that kind of. It's in carburetors. There's gas circuits and air circuits and whatever.
The family circus.
Oh yeah. But with temperature, the idle settings will change in hot weather. Now, fortunately, she'll probably be able to set it from now and have it run the rest of the year up until
February,
October, whatever.
We got 2 weeks in winter.
And then she's going to have to go adjust it up a little bit and richen the mixture a little bit. You're lucky on that Solex carburetor. There's only 2 screws, so you really should be able to figure that out.
You got a 50-50 shot.
Well, you're going to have to do both of them, but you get to a point where you'll figure that kind of stuff out. But yeah, you're going to have to adjust timing periodically. That 42 is not far removed from the days when you had the timing advance lever on the steering wheel of a lot of vehicles. Okay, you retarded it to start, and then you pushed it and advanced it for driving. And if you wanted to go really fast as you built up speed, and when you got to 30 miles an hour, you advanced it all the way because you might make 45 and 50. And if you forgot it when you slowed down, the engine literally stalled, backfiring because the spark was happening too soon. And so you learned to pull it back.
When you stopped in 800 feet.
Well,
because believe me, then that 50 or 48 Packard ain't stopping on a dime.
No, but
it's stopping on.
I'm thinking about even further back than that, but gotcha.
10 Brinks trucks.
Well, some people use the back of a bearing stalk because
That's that new Ford anti-lock brakes. It uses the car in front of it to stop, but the brakes never locked up once.
So anyway,
Sorry,
sidebar on that one. Yeah, it's kind of fun to see where technology has gone. It's even more interesting to me, although some cases a little sad when I see where our modifications are going due to a lack of understanding of how it works. And so in the issue of differentials, I can't tell you how many differentials I've seen that, front pinions died due to oil starvation. At the shops I've been over to many times, and it's to the point now that the shop managers know.
When they crack open that case and find an entire bunch of chiclets in the bottom of the differential.
Yeah, silver chiclets all over the place, and it smells kind of like the creek running out of the back of the barnyard from the pig pen.
Burnt gear oil is the worst smell.
It's horrible.
Oh, my God.
And then people are looking at him because he goes, yeah, okay, well, you destroy. Okay, can you replace the gears? Yeah, and you'll need the new pinion. Well, why? Because the teeth ate the the bearings and by the way, the ring gear and the pinions
You
and
crack
the
the
carrier. And then we got to get axle bearings and wedding bands. What's the axle bearings got to do with that? Well, that's the same oil and took all of the
and the seals.
man glitter out to the
Wedding bands. I'm not marrying my Jeep. Oh, you did, young
You
Bucky. You
did.
did.
love, honor, and obey.
Ooh.
The old version with the Jeep being in the dominant role.
Literally, the hood's out there going, feed me, Simo. I'm hungry.
Yeah, that could be. So that's why I kind of stressed this subject. I thought it would be a good show. I hope you all liked it. Feel free to email, ask any questions. It is going to be, it's an interesting world when you look at it. Most people forget about the secondary usage of lubricants as coolants in the automotive engine. Something like 40% of the engine heat's dissipated through the oil. Transmission, virtually 100% of the heat is dissipated through the oil. Your transfer case, 100% is dissipated through the oil in the case. Differential, 100%. So it does pay to get a good quality brand. It does pay to have one that has a very high thermal stability. That's a challenge because not a lot of them are marked that way.
Yeah.
Usually if the manufacturer went forth the effort, they'll put it on there, as far as a notice on thermal stability. I've had good luck with what?
As I'm sitting here going, oh, crud. Last time I did the differential service in the Gladiator was 30,000 miles ago.
Okay, well.
Guess who's one change behind? Oh, man.
Oopsie. Oopsie. So this is just one of those little lifeblood information. I'm sure there's exceptions to this. In fact, I know of some of them, but we could go on for another hour or two in the show talking about exceptions. The key is you need to think it through. Don't believe everything the packaging says. Pretty straightforward.
There is marketing, kids.
There is marketing. But if you're doing a lift, if you really need the high angle pinion, there's an answer to that. You get a high pinion differential. Is it cost more? Yes. But you can only lift a low pinion. That's where the pinion, the drive shaft input flange is below the center line of the axles. That's called a low pinion. You can only lift that so high before that bearing starts. If you put a high pinion in, it's already designed to run above the oil bath. And it has larger flow ports and a better oil delivery system to have that bearing up. And therefore, angled up is less of a problem for it.
It's already engineered for it.
It's already engineered for it. So if you're really going for the radical lift, the honest suggestion on my part is factor in the cost of a high pinion differential, and you'll be happier, and you'll probably walk a lot less.
Well, another thing, too, as all the listeners send us emails and messages, and it's great. We love the emails and messages, but sometimes people step outside the realms of some of these things we actually need to see and be there when we start diagnose. So by all means, keep the emails coming. We will absolutely help you when we can, but we can only offer really suggestions on a lot of ideas when repairing and fixing your vehicle.
And referring to that right now was...
Yep.
Okay, we're both drawing a blank here.
No, I know the gentleman that emailed us about the PSC power steering box.
Yes.
And that's the thing. We want to keep the emails coming because, again, you're not the only one with this question. But at the same time, getting specifics is really great. That gets us a lot of the information. So Kevin and I can really only diagnose as far as, ideology.
Yeah.
Help me out here. What's the big word I'm looking for, Kevin?
I'm sorry. I was doing research trying to find something here for a reference of an email.
No, that's fine. No, but again, we will definitely, like many times, a lot of our listeners have said, "Wow, Kevin, you really dove into the information, and you do get a lot of great information and research with your emails." But again, some stuff is just, again, you need to be there a little more. There's more questions we need to ask. Well,
and let's go in, and I'm going to answer Brian back here. Sorry it took us a while to get back with you, but we decided it was a good show topic. And Brian has a 98 TJ Sport with 05 Ruby axles. He upgraded to a JK steering system. He's got 106,000 miles on it. A 5.5 Rubicon long arm lift, and he runs 35 12.5 by 8s. He had kind of loose steering problems, and he kind of attributed it to slack box. So he got a big bore PSC box. I like PSC box. I've got that on mine, not the big bore though. With new lines and corrected the loose steering. But when he was doing a fast turn, so coming into a parking lot or a parking space where you spin the wheel really fast at low speed, it would feel like the valving would kick back. He said, but otherwise normal driving was good. Did a fast back up in a turn in a hurry, and the steering wheel slid out of his hand. So the pump, the valving actually took over for him. He's replaced the pump, and with a new SC pump, same thing. Called PSC, they sent a new box, same thing. Called a third, and they sent him a third box and a second pump, and has the same problem. He reinstalled the factory box and pump, and it was fine, except that the play while driving down the road was as before. He could turn fast, bled each box, blah, blah, blah. Do I have any suggestions? Brian, yeah, I got a couple of things, but these are only suggestions because, of course, I can't accurately see and recreate what's happening. But there's a couple of things that could be driving this scenario. And it has to do with the fact that you're running a PSC box and a 98 TJ. And it has to do, let's start with the one that I had problems with my PSC box. And it turned out to be, believe it or not, my intermediate steering shaft, the slip joint. All right. Understand how a box works. There's a sliding valve in there. When your input from your steering shaft connects to that little spline shaft and it goes in, it doesn't actually make a hard connection to the worm gear assembly below it. It's got a plate in there with a pin that deliberately has a little bit of motion in it. Okay. Loose steering. But that pin actuates the hydraulic valving is the best way to think of it. So that little bit of free play as you turn to the right makes the pressure in the ram push the selector gear to the right to follow it.
Right.
And when you turn to the left, the pin moves the left side and it pulls the steering back to the left. In theory, you could adjust it to the point that you never actually, the actual bore piston never let that pin touch, okay? But they do set it up so that it actually does make mechanical contact. And it's a very small amount. And that's usually why you have loose steering in worn-out boxes is the seals are so loose that the little bit of hydraulics that would normally keep it fairly centered aren't there, and you have to get up to you're pushing hard for it to actually put power to the selector piston that's moving in the bore. So what I'm hearing, though, when you say that it's pulling it back out of your hands, that to me says something's going on in that bore selector that's moving the piston. Where mine was the slip shaft was frozen. And your PSC box is not exactly the same length as your old box. All right. And I don't know which box you had, but if you didn't have trouble putting it in, I expect with the 98, okay, you have the Saginaw, not the Mercedes-Benz box. So the Saginaw box, the big bore box is a different box. It's a slightly different dimensions. And if your steering shaft is not loose enough in the crash zone, there's that little slip area there between the box and the knuckle joint, if you know where I'm talking about, that it's got a little plastic pin in it. It can get longer or shorter if you're in an accident so that the steering column doesn't come up and punch you through the chest.
Right.
I would tell you by now, with a 98 at 106,000 miles, and you didn't say where you are,
Yeah.
but I know even here in Florida, mine was rock hard.
Yeah.
It didn't move. And it took me taking it out, putting it on the bench in a vise, spraying it with lubricant, tapping with a hammer in, pulling out until it moved. Now, it's not going to move a lot because it's pinned. Although in theory, you could let it slide. In fact, when you change from the Mercedes box to the other one, that's what you do. You collapse the column to get more room. But you could be just off enough in your tolerances that your steering wheel, when you're steering it, you're actually putting pressure on that shaft in or out, and you're making that valve move, which would activate the hydraulics. All right. That's one option. The other thing to check is, I know you said you put new hoses on, but new doesn't always mean good or perfect. If you have fluid flow that gets between the inner wet liner and the outer structural liner, and no, it doesn't always leak out. I had burr brakes that locked up because I had a gap in the crimp on the inner liner. It had gotten rolled, I guess, when they pushed it on, and then they put the crimp on and crimped it. And what happens is the pressure gets in between them and it blocks off one of the lines. And all of a sudden your pump overloads, goes into the poppet valve, and then as the pressure bleeds off and the line opens, all of a sudden you get a rebound jerk backwards. So you could, not highly likely, I'll be the first one to say that, but the lines, your new lines could have a problem in them.
Yeah.
If they didn't do it with the older box when you put it back in, that may say that the lines are okay, or, but I'm not sure. I'll bet you, though, that if you take your steering shaft, take a hard look at it, is the center bearing, that's the center ball that you see right above the driver's inner fender that the shaft goes through, is that loose? Is it broken? Is it wobbling? Is it missing? Yeah, as Scott says. Yeah. If that's wobbling, that can also trigger steering input because your steering isn't balanced. When you turn it, the shaft is wobbling instead of turning. But when it gets past a point, remember, you got a little U-joint in there, usually a little crusty, musty one.
Yeah. That never sees oil or anything. It's like a little mummy, and they're going.
Exactly. And if that is jumping around, again, if it jumps around because it's got a hard spot in it, it will put the input shaft into your box to jump. And, of course, that's the same thing as you bumping your wheel hard to the right or to the left. And it can put it on or it can take it off. And you have a big bore box. And I'll be honest with you, with your tire size, I think a big bore box might be a little overpowered for your steering, because I know that in my 05 TJ with a early model PSC box, in other words, it's a new one, but it's based on the long-nosed 700 series Saginaw box as opposed to the little short-nosed Mercedes box. So I had to convert back to I used the collapsed steering column for a while, and it was horrible. It was absolutely horrible at the way it behaved. And I was really frustrated with it. In fact, Scott knows I had an ABM box to start with, and then I changed it to the Saginaw to the PSC box because I thought it was the box, same as you had. And it turned out to me it was that steering shaft being shortened, wasn't moving enough to give end-to-end play, and that center bearing was just absolutely trashed. It's a plastic ball that's got two halves and a rubber housing, and inside that is a caged needle bearing set that mine was mummified orange dust. And it took me finding some parts in the junkyard, taking everything apart. I broke down because I could not get a factory new part at that time. I think somebody is making them now. I'm not sure if that's Crown or one of the folks. I have seen what appear to be new. The other one is the steering shaft. I just broke down and went Flaming River top to bottom. And you know what? After I got the shafts and the bearing back in, my steering cleared up and handles great. So that's the only suggestion I can give you. The guys at PSC know their boxes inside and out. They know their pumps inside and out. I'd be surprised if you have a hose problem, but I got to tell you that because I've had that happen.
Yeah.
Okay. And that was on new hoses. That's the worst part. So that's one thing that when hoses break, power steering, any of these hydraulic system hoses are made, nobody pressure tests them, okay, dynamically to see if the inner liner's, got a pinhole in it or a bad crimp or whatever. And if you do get fluid in between the outer jacket and the inner jacket, Scott, first thing he said when I brought that up to him earlier, he's like, well, wouldn't that weep? And I said, nope, mine didn't.
Yeah.
But it would pressurize. You could pump the brakes on and the fluid would hit the wheel cylinder, expand the brakes. I would stop fine, but it would also flow into the joint, squeezing the inner liner down and constricting it like a closed, little pump valves on a blood pressure cuff.
Yeah.
It was like one of those, and it was tight. And I would take my foot off, and the rear brakes would be locked. And I would sit there cussing, and I took a break, and I went and called a friend. And by the time the friend came out, guess what? I Jeep fired up and drove like it was nothing. The pressure bled off. Yeah. As soon as I did a hard stop again, and it didn't do it on a gentle stop. It only did it on a hard stop. Well, in power steering, it's always a hard stop. Your pump runs full pressure constantly with the bypass only popping if the fluid flow is blocked. So,
well, I don't mean to interrupt you, but this is Tales from the Parts Counter.
Yeah.
And do defective parts happen? Yes, defective parts will happen. That's just the nature of the business. Mm-hmm. Getting two defective parts with the same symptoms, not saying it's uncommon,
rare.
But it's rare. But the other to answer the question, why did it behave better when I put the old parts in, and I still had somewhat of a problem, but not as bad. Parts wear at the same rate.
Yeah, they wear together. What we call it.
Wear together. And so when you put a new box in there, things will be twitchy, especially if you're having that steering shaft issue like Kevin's talking about. But yet when you put the old boxes back in, it's less twitchy because they're slop.
Yeah.
Because those parts weared evenly.
Yeah.
So those are just things to think about because, again, I can't tell you how many times I've handed the same part over the counter several times. And turns out it was, again, same thing we're working through now with the GPW. Failure of other parts mimic a defective part, the new one you're hanging on. Like some people would say, oh, well, we got a defective fuel tank. The siphon or the pickup tube isn't welded correctly. Well, it most likely is a fuel pump getting weak.
Right. So
it's just something to think about.
So you basically, I'm just suggesting that you check the rest of your steering linkage system top to bottom. Mm-hmm. And I'm talking about from the steering box up to your steering wheel. Understand that at the bottom of your steering wheel, you have that shaft inside the cab, you have a bearing and a U-joint. Those have never seen the light of day, much less service, I probably bet you. Okay. Yes, you have a bearing up at the head end where you steer, but you'd feel that as the wheel being wobbly. And then it goes through the firewall, and it comes to another U-joint, okay, and that ball bearing, and then it goes down to a final U connection at the box. So you have 3 bearings at least, and then the one center ball bearing that is supporting, and I call it's not a ball bearing, it's a needle bearing in a ball. Yeah. And it's sitting there on your fender, and it's the brace in that middle section shaft. And if the U-joints are frozen, the PSC being a new box, it's going to be tight, sensitive, instantly reactive. Hence, you don't have the wobble. Mm-hmm. But as you're turning, the shaft could be causing your problem. And with the symptoms you've given me, I would say it's definitely worth a look.
Yeah.
And it may, and like I say, in my case, I spent a day, took the driver's seat out so I could lay down as well as you can in a TJ and get underneath the dash, unhook the steering column. I literally pulled the column out, pulled the intermediate shaft and the lower shafts out. And in fact, I think I still have the one still sitting out in the scrap metal bin. And I had one of those little pivot points was rusted solid.
Yeah.
And so it was doing the chunky dance. And so if you're steering along there and you get that kind of a sudden reaction out of it, either direction, it can pop either way. Mm-hmm. If you've ever had a U-joint that's got one froze needle, you'll know it because you've driven along and you've made a turn, you heard this pop, 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 and you feel like it's punching you in the butt. Same thing can happen in a steering shaft. So I'd look there.
Well, plus also that bearing and that U-joint is on the exhaust manifold side. That
the one under the dash is at your feet. And of course,
Yeah.
you've never had wet, muddy feet up there.
Oh, of
right?
course not. Yeah, and the seal between the windshield and the cowl never leaked. But again, the plastic bearing, again, like you said, when you had mummified orange dust as lubricant,
Yeah.
again, the same thing. They get heat cycles, heat.
Oh, yeah,
soaks.
those are terrible. And mine comes apart now about once every 2 years. Because I'm paranoid over it.
Yeah, mine's never been taken apart once. So
Yeah, well, we looked at yours and it seemed to still be alive.
Yay.
The weird thing is there's no way to grease that without disassembling.
Yeah.
And that's, you got to take rusty bolts off the bearing flange and
Yeah.
then pop it out and then split the little plastic ball and see if you even have a bearing left.
Well, I think when we did because you had the extra steering box, you checked that because that was right
Yeah, I
around the
checked yours,
time you were having that.
Yeah.
So, but anywho.
All right, folks. Well, Brian, again, sorry for taking an extra couple of weeks.
Yes.
But we ran a little long on the last show where we were going to answer it.
Mm-hmm.
And so it's out on this show, and I almost forgot it, thanks to Scott for going nudge, nudge. And, it's been kind of busy, and it's going to be a busy summer for us. Like, I still have to go up to, I'm doing the Bantam Jeep Festival, as well as a lot of other round robin from D.C. all the way up through Pennsylvania, and so I've been back down again. Through some old home times.
Yep.
And then we will be heading to Sheriff's Jeep Fest in Pickens County, Georgia, this fall over the Labor Day weekend. That's a great event if you've never been and you want to go play in the Georgia woods. And get red clay absolutely everywhere.
Speaking of red orange dust,
Yes. It's definitely a great event.
Absolutely.
It's a great event. So,
cool.
with that,
I think it's time we lock the hub sheet, put the Jeep in 4 low, and hit the trail.
sounds good to me. Remember, please take nothing but pictures, memories, and of course, take your trash with you. We want to keep the trails open for everybody, including our kids, grandkids, and maybe a few generations beyond that.
Exactly. So with that, we're going to bid you do is catch on the next show, which will be 186. I remembered something, numbers. And with that, we shall bid you adieu. Bye.
Bye.
Proceeding has been provided for entertainment only. Proper service and repair procedures are vital to the safe, reliable operation of all motor vehicles, as well as personal safety of those performing those repairs. Standard safety procedures and precaution, including the use of safety goggles and proper tools and equipment, should be followed at all times to eliminate the possibility of personal injury or improper service which could damage the vehicle or compromise its safety.
What he said. Thanks a lot for listening, guys. You guys have a great day.
Bye.
This has been a Bent Axle Media production.